Today's stuff is not hard in any stretch of the imagination, but I will tell you, it is confusing. Okay? It is called, with exponents, the laws of exponents. Okay? And what we're looking at are three different cases here. What happens when you multiply things that have exponents? That's case number one. What happens when you divide things that have exponents? And case number three, my personal favorite, is what happens when you have exponents to exponents. Okay? If you break it down and just kind of do it out, it's really not so bad. If I asked you what x cubed times x squared is, anybody? It's not a hard thing, we've actually done this before. X cubed times x squared. This times this. Maybe it becomes clear if I actually do it out. X cubed is the same thing as x times x times x. That's x cubed. If I multiply that by x squared, which is x times x, here's my x cubed, here's my x squared. If I multiply those two together, I end up with, ladies and gentlemen, x to the what?
Never mind.
Fifth power. And Taylor Pavia, that is why this is confusing, because it's multiplication. With the laws of exponents, when you multiply two bases that have two of the same bases together, the rule is this: you need to add exponents. Okay? You need to add exponents. In other words, if you have x to the 7th times x to the 8th, you don't get x to the 56th, you get x to the 15th. Now, Taylor, and all of you, if you get it here, standing, sitting, you need to write it down somewhere so that you don't lose it tomorrow, because that's what will happen again. That's just the way it works. Just the nature of the beast, okay? Now, this one here, okay, if I have x to the 3rd divided by x squared, again, if you think about this, same way we did over there, if I have x times x times x over x times x, what am I going to end up with? Anybody care to speculate? Knowing that you can cross-cancel the same like things on bottom with like things on top. Gabe? Just an x, because this x crosses off with one x on the bottom, this x will cross off with that other x, and you're left with one solitary lonely x. And we don't usually put the one exponent there, but I'm going to put it there for posterity's sake. Now let's go a step farther, give you another example. If I have x to the 15th power over x to the 8th power. I'm going to end up with Zach.
X to the 7th power.
X to the 7th power. Okay. The laws of exponents with regards to division are not to add like multiplication, but actually, in this case, you are going to subtract the exponents. That's our rule when you divide. To divide, you subtract. And now, did I say it was my personal favorite? I think I did. I guess I have to do that like this. X to the 3rd squared. Anybody care to speculate what the answer to that is? Love it. Sam Poppin.
X to the 6th power.
X to the 6th. Ava, you agreeing with that?
Yeah.
Really?
Yeah.
Nate?
X to the 9th power.
Nate says x to the 9th power. Interesting way that works. Let's think about what this means. x to the third squared means that you have x to the third times x to the third. It's this thing times itself. Okay, which means it's x to the third times x to the third, which for those of you that said the answer was x to the sixth, you were correct. Okay. Now let me give you another thought-provoking one here. I wish I had some more room, but I ran out. What if it was x to the eighth to the second, well, to the third power? X to the eighth to the third power. Now notice these exponents are right next to each other. People get that confused with this. I didn't say x to the eighth times x to the third. It's x to the eighth to the third power. And the survey would say, Ashley,
X to the 11.
it is not x to the 11th.
Wait, oh, no.
Demetra, it is x to the 24th power. And the rule of that is exponents, two exponents get multiplied. Multiply exponents together. And we will do a bunch of examples in just a second to make sure that you kind of have some sort of firm grasp of some sort of reality somewhere here. Let's jot all of these down here. I'm going to stick up here a slew of problems here. Number one, let's go with 2 to the third power times 2 to the second power. Number two, let's do 2 to the fifth power over 2 to the third power. Third one, let's do 10 to the sixth times 10 to the third. And 10 to the sixth over 10 to the third. And I must have missed one here. How about, yeah, and then 2 to the fifth power squared. Take a look, see here. Okay. We're just going to, I'm going to let you leave it in exponential form rather than doing it all out. Okay. 2 to the third times 2 to the second power would be 2 to what power? 2 to what power? Good check. 2 to the fifth power is correct. Because here you have 3 2's times another 2 2's, you have 5 2's times themselves. 2 to the fifth power over 2 to the third power. When you divide, by the way, they have to be like bases. If this was a 6 down here, you couldn't do this stuff. These have to be like here. If you have 2 to the fifth over 2 to the third, you end up with, Josh?
2 to the second.
2 to the second power, because you subtract exponents. Number 3, 10 to the sixth times 10 to the third. Again, we are multiplying exponent bases with exponents there. Taylor?
10 to the 18th.
It is not 10 to the 18th. You have 6 tens times another 3 tens. How many tens do you have times themselves? Nicole?
9.
9. Look at the little rule. When they get multiplied, you add exponents together.
Oh.
10 to the sixth divided by 10 to the third. It's the same as this one. These are exactly the same. Bases, all one. 10 to the sixth over 10 to the third. Colton, shoot.
10 to the 9th.
It is not 10 to the ninth. If you look on your division thing, what do we say to do with exponents?
10 to the 3rd.
10 to the third, thank you very much. And my personal favorite here, 2 to the fifth to the second power. Okay, and you have to recognize the difference in this and that, because there is a difference. Bailey?
2 to the 10th. Or 2 to the 20th. Right?
If you look in your things where I put exponents to exponents, what's it say to do the exponents?
Multiply.
So 2 times 5 is? Now again, let me break it down. Bailey, because this will help you out. This is 2 to the 5th squared. That means you have 2 to the 5th squared means it's times itself. And 2 to the 5th times 2 to the 5th is 2 to the 10th, just like we added exponents here.
Wait, so I did 5 times 5.
Right, you did 5 times, you squared 5, you didn't multiply it times 2. You multiply these things. This is what we need to do to get our answer. You don't square 5, you multiply it by 2. Just like this, if you had 8 to the 9th power to the 5th power, exponents, 2 exponents, you just have to multiply these two together. That is 8 to the 45th power. Okay. You don't take 9 to the 5th power, you just multiply these together to get that. Carolyn.
Will the two numbers that you're dividing and multiplying always be the same?
Not always, but if they're not the same, you can't do anything with it. You're saying, are you saying something like this? If I have x to the 3rd times y to the 5th,
Yes.
children, Carolyn makes a great point here. If I have x to the 3rd, y to the 5th, okay, I can't do anything with that at all. You don't get xy to the 8th power, okay? These cannot be combined or done anything with unless the bases are the same. You just have 3 x's times 5 y's. And you can't put them together and say it's xy to the 8th power or any of that stuff there. They have to be the same bases. Everything we've done has had the same bases. These were 2's, these were 10's. Even if you go back to here, these were all x's here. None of that other stuff. Oh, it looks impressive, doesn't it? Yeah, x's forming over the place. Somebody else. Taylor.
Is there a certain number that your exponents can go to, or is it just
Infinity is it.
Okay.
They get awful big though if you start going there. Kendall?
when it says x times y, if we ever have that on our homework assignment, we just written like x times x times x times y times y.
Tell you what, give me an example. Tell me what to write on the board. X.
Like x to the power
X to what power?
times y to the second power.
Times y to what?
Second power.
And you're asking me, what is that?
So we just put like 5 x's and then 2 y's.
Well, that is as simplified as it gets. It does mean x times x times x times x times x times y times y, but I don't know why you want to write that down like that.
Like for our homework, so around.
It's on your homework, this is it. There's nothing more you can do with that. Now, if you had, if you have something that looks like this, and I think we've already done this, x to the 5th, y to the 3rd, x to the 8th, y to the 2nd. You can put the x ones together, x factors go together, x to the 5th and x to the 8th combine to give you an x to the 13th power, and a y to the 3rd and a y to the squared combine to give you the y to the 5th power, but you can't do any more than that when you combine them and put them together. By the way, kids, don't worry.